So welcome back to Pharma-info with Shubhashish. Now today's topic is Wolff-Kishner reduction. So in this session we are going to cover up reaction at the same time mechanism, the reaction mechanism actually. Fine. So we all know about the reduction. Fine. Assume that we are dealing with a ketone, right? Or rather a keto compound, right? It can be an aldehyde, it can be a ketone, right? We all know that it is the carbonyl group that is found to be the part and parcel of what? Either ketone or aldehyde, right? And if your job is to convert this C double bond O into CH2, then several reduction reactions, right, were proposed by what we can say a diverse range of scientists, right? We all know about Clemmenschen reduction. It's a very popular one, right? Clemmenschen reduction. Okay, Clemmenschen reduction. And we all know that what are the reagents, combination of reagents. We all know that it is zinc amalgam and HCl. And here the HCl is found to be a concentrated one. Fine. So it is the zinc amalgam HCl that is basically used, okay, to convert a keto into a methylene. Fine. Because here earlier it was a keto moiety and keto gets converted to CH2. Fine. So in Clemmenschen reduction, we are basically, and it's an acid sensitive reaction, what we can say. Fine. Because as we are using concentrated HCl, so what we can say, because all ketones or aldehydes, they are not found to be acid resistant, what we can say. Fine. So if they are found to be highly vulnerable or sensitive towards an acid, right, what will happen? We have to opt for another way by which the keto can be reduced. Fine. So that means what we can say, we need to search for a reaction in which the same thing, that means we are going to convert the keto to a CH2, fine, or keto need to be reduced, fine. But since the keto which we have taken, right, that is found to be acid sensitive, in that case we need to find an alternative, right? And the best alternative is nothing but Wolff-Kishner reduction, fine. So the one which are found to be acid sensitive, in that case we are basically opting for Wolff-Kishner reduction. So here also we are doing the same thing. That means we are converting the C double bond O into CH2, but here the combination of reagent seems to be different, right? No longer it's zinc amalgam HCl. Rather we have to take what? We have to take, it is basically base catalyzed, what we can say. In case of Wolff-Kishner reaction, we are running the reaction in presence of a base. It's a base catalyzed reaction, fine. So anyway, without wasting time and all on this Clemmenschen as well as Wolff-Kishner reduction, let us just straightway take the main thing, right? That is Wolff-Kishner reduction, fine. So here we are taking what? As I said, we are taking a carbonyl compound, right? It can be an aldehyde, it can be a ketone, fine. Chalo. So this is the first one, right? Along with this, we need to take what? Hydrazine, that is H2N and H2, fine. This is the thing, right? And as I said, it must not be acid catalyzed, rather it's a base catalyzed. So the options are KOH or NOH, fine. Because any of this, either of them, okay, can introduce the OH minus, okay, and can make the environment basic, fine, and thus it can release OH minus, and this OH minus will take the rest, fine, or rather will be involved in proceeding the reaction towards a forward reaction, fine. So now what happened here? So if this combination, that means a keto at the same time hydrazine, KOH or NOH, right, what will happen? What am I supposed to get? It is the RC double bond O that is getting converted to an alkane, right? Because after all, earlier it was C double bond O. Later on, this C double bond O, after catching hydrogen, gets converted to CH2, fine. So this is found to be the reaction of Wolff-Kishner reduction, fine. Now let's see the mechanism, right? The mechanism which is being followed over here. Now let's see the mechanism, the reaction mechanism. To be more precise, okay, I should write here reaction mechanism. Let's see how it proceeds. As I said, it's base catalyzed, right? And now let's see, and there is an influence of water as well. We'll see in the latter part, right? So initially, what happens? So let me just do one thing. Let me just put the structure of ketone first, right? It is the ketone. Initially, it will try to access what? The hydrazine. So what will happen once the ketone is interacting with hydrazine? So this is your hydrazine, and this one is your ketone or aldehyde. Anything, right? Fine. Chalo. So what will happen once the reaction is on, right? We are supposed to get what? We are supposed to get hydrazone through elimination of water. from here H2, from here oxygen. Fine. So what will happen? The resultant thing is found to be a hydrazone, and that is found to be like this: NH, NH2. Now, right, as I said, H2 at the same time oxygen, there is no point in keeping this hydrogen. That should not be there. Fine. So hydrazone is the one, because if I just put hydrogen over here, what will happen? 1, 2, 3, 4. Nitrogen is trivalent. Definitely I need to put a charge. But since this one is hydrazone, not a reactive species, so that is why hydrogen should not be there. Fine. So that means hydrogen should not be there. Fine. Chalo. Because elimination of H2 at the same time oxygen. So what is left in the process? NNH2. The same thing here, NNH2. But here the connection remains same. That means earlier it was double bond. Now also it is double bond. Fine. So this is called hydrazone. What next actually? Fine. Now let's see what next. Now here comes the important of the role of what? Role of a base, right? So what this base will do? The base will try to, access what? So I'm just simply putting here OH minus, because this is found to be the reactive, element, what we can say, or reactive species, right? OH minus. So what this OH minus will do? The OH minus will try to catch up, hook one hydrogen from this portion, from this terminal, right? So what will happen as a result of it? There is a formation of water, yes or no? There is a formation of water, right? So once the water is getting eliminated, so what is left? What will be the, what will be the form that this particular intermediate will acquire? I mean to say the hydrazone need to acquire a certain form, and the form is something like this. So upon elimination of water, this gets converted to R, C, double bond, N, then NH minus. Because here deprotonation occurs, what we can say, deprotonation, fine, deprotonation with OH minus. So if I just write here deprotonation, okay, that will be good for your understanding. Fine. So here what I have written here, so once the H plus has been taken off, what is left in the process? The pair of electron which was earlier been shared between nitrogen and hydrogen. Fine. So that is, now that has become one anion. That means a charge has been developed over here. Fine. Chalo. So this is found to be the intermediate that is getting formed through hydrazone with the able interference of what? OH minus. That is from base. So this is coming out from base. Fine. Now what next actually? What next? Now definitely as I have written here, say a charge over here. This charge will no longer try to stay over here, right? So as the charge will no longer try to stay here, what will happen? This charge will try to come here in between this nitrogen. Fine. This charge will try to come here to form a bond, right? So what will happen to this? Definitely this will get broken, right? And this will get broken. So here comes the role of water. If I just present water in this form, what will happen? Once the electron has been given to this proton, what will happen? This will definitely come here. Fine. And thus this intermediate is getting converted to R, C, H. See, partial hydrogenation has already been taken place, right? At this very moment. Fine. We have this, and then followed by NH. Okay. So this is the thing that is getting formed, right? This is the thing that is getting formed. Okay, let me just write it in this one. Right. So what happened here? So here this electron came here. It is through delocalization of this particular charge. It came here to form a double bond. This double bond has been formed here. Fine. Then what happened? So once this came here, what will happen? Tetravalency develops. That will no longer persist over here. So that is why this pi bond should change its location from here to here. Fine. Now once it came here, what will happen? It will try to access the proton of water, right? And the proton has been taken back, or rather taken up, right? Fine. Leaving behind OH minus. Fine. And this has happened over here. So this is the thing that has been formed, right? So here we are approaching to the final compound. See, it has been this carbon, which was earlier was in the state of C double bond O, has been partially hydrogenated. Fine. Still we need to incorporate one more hydrogen, and how this can be done? In the same way, right? Here also, as I said, it is a base catalyzed one. So that means again we need to bring what? A base. So what this base will do? The base will again try to come over here. I'm just writing here base, right? For my convenience, right? So what this base will do? This base will try to catch up another hydrogen from here. Fine. Another hydrogen from here. Chalo. So once this base will try to catch up another hydrogen, assume that it has been accomplished, right? So what happened here? Through elimination of water, what is the intermediate that is getting formed? R, C, H, R, N, double bond N, on top of it we have a charge. Again the charge, the same thing, right, which we observed here. The same thing which we observed here, right? There is an appearance of or development of a charge. Why? Because the H has been taken not in the form of H minus, rather H plus. So that means again here I can write deprotonation. Fine. It is the deprotonated or deprotonated proton, right? So that is basically mingled with what? The OH minus to form water. Thus I have written here dehydration through deprotonation. Fine. Chalo. So this is the intermediate that has got formed, right? Then what next? Ab hona kya hai? Now again what will happen? The charge will no longer stay here. It will just try to relocate itself, and this will come here, approach its neighbor, fine, to form another pi bond, right? So what will happen to this? Definitely this bond will be broken, fine, and this will come here. Again it has to take the help of what? The water molecule. So here let me just write water molecule, fine. This water molecule, right? So what will happen? This water molecule, because this electron is available for this proton, right? It will be taken up, right? So once this will be taken up, what will happen to this? Through elimination of N2. Why? Because now the nitrogen gas has been formed, right? Nitrogen gas is N triple bond N, which has been formed over here, and this bond has already been broken. So nitrogen definitely will get, the evolved nitrogen will get eliminated, right? And here what happened with the assistance of this particular bond, what happened? The proton has been linked to this particular carbon. So this has happened like this: R, C, H, again H and R. Fine. So this is the thing that has been formed. Now are we able to relate this with that? Are we able to relate this with that? Yes, of course. Initially it was a carbonyl, right? Initially it was the carbonyl. Now this carbonyl has to change itself into a CH2. Now initially we started from here, ketone, hydrazine, formation of a hydrogen. It is the base that is trying to catch up one proton, right? And thus there is a formation of a charge over here. This charge will come here to form a pi bond, right? As a result of it, the neighboring pi bond will get broken. It will come here and it will try to access what? The proton of water molecule. Okay, accepted, fine. And then what happened? Now from this this has been formed, right? Again the OH minus, that means the base will come here. This base will try to suck up another proton from here. So deprotonation followed by dehydration will eventually give rise to the production of what? Production of this kind of thing. Another charged ion, fine. Charged ion, fine. Negatively charged ion, fine. Now this charge again relocate itself from here to here. There is a formation of a triple bond over here, and the moment the triple bond between nitrogen and nitrogen will take place, or okay, so what happened? Elimination, there is the evolution of nitrogen which will no longer been captured, right? Fine. It is not in the form of a solid, rather it's a gas, so that means it will get eliminated. So through evolution this will get eliminated, and after that, once this has been done, right, what happened? This bond will get broken and this will come here, and the same process is repeated, fine. So here again water molecule is there. Through that water molecule it will try to suck up one proton, right? OH minus will get eliminated, and what will happen? This will get formed. So this is all about here the mechanism of Wolff-Kishner reaction, right? Let me do one thing. Let me just write the applications, right? Applications are very simple. So if you are dealing with a ketone, I mean to say the examples, right? Examples. If you are dealing with a ketone and your job is to convert the ketone into a methylene, as I said, it's a good alternative to Clemmensen reduction, because in Clemmensen reduction, say all the ketones are aldehydes, they're not responding because it's an acid sensitive reaction. So that is why if your job is to deal with a sensitive, acid sensitive, ketone or aldehyde, then the best option is, best alternative is just to run, reduction through by following Wolff-Kishner principle. Fine, Wolff-Kishner reduction principle. So here we are taking what? The hydrazine in presence of a base, a strong base, of course, right? And things will be taking place, at ease, right? So if your job is to convert a ketone to a methylene, right? So Wolff-Kishner, suppose ki, okay, so this is found to be the one. Suppose ki you are dealing with acetophenone, right? Acetophenone, and you are going to convert acetophenone into ethyl, benzene. So what will happen? So by following Wolff-Kishner reaction, that means H2N NH2 in presence of a base. So what will happen? What is expected over here? So now this will get formed. So C double bond O is getting converted to CH2 and finally CH3. Thus we are getting what? We are getting one ethyl benzene. So one ethyl benzene is found to be the final product. So our starting material was acetophenone in presence of hydrazine as well as base. This gets converted to one ethyl or simply ethyl benzene, right? Chalo. So with that we are done with this Wolff-Kishner reaction, right? Wolff-Kishner reaction. Hope you So probably, okay, I believe that this illustration is clear to you, right? If there is any doubt, let me just do one thing. Let's just project it in a proper way, right? So that at least you can refer this one, right? Chalo, fine. So okay. So this is all about your Wolff-Kishner reduction. So hope you understand the fact and file, right? And moreover, and it's good to see in the comments that the kind of or the topic that you want me to discuss, right? The same thing, okay, for this session also. Let me just leave this message. Please put your comments, and in that comment, please let me know that what is the topic that you want me to deliver or discuss, right? So thank you for watching this video. So see you in the next video. Thank you.